Hi guys, my name is Muhammad Shafiq and I'm going to explain to you guys the introduction of our project. In the structural engineering, truss is one of the most important structure type for bridge design modeling. A truss is a system of triangular system that are arranged and connected in such a way that they only experience axial force. These members are considered double strength members because the force is applied only to both ends of the member, resulting in a force of pressure or tension. They are commonly used as bridge designs that give their ability to reach a long distance efficiently. They also are a very strong, well-received and cost-effective option for building a variety of structure.
Assalamualaikum. Our initiation of the research of the Pratt Truss was prompted by our desire to unravel its secrets to its design that withstood the test of time and remain one of the best in efficient weight distribution, ease of construction, and adaptability to varying spans. One such application of the Pratt Truss is none other than locomotive bridges. The further evolutions of bridge engineering catapult it beyond the horizons that we have no sights on, ensuring that it will be utilized in the near future.
A Pratt truss is a type of truss structure commonly used in bridge and building construction. It consists of vertical members, posts or columns, and diagonal members inclined toward the center, forming a series of V-shaped patterns. The top chord, the horizontal member at the top, is usually shorter than the bottom chord, the horizontal member at the bottom, giving the truss its distinctive shape. The primary purpose of the Pratt truss is to efficiently distribute the load, such as the weight of a bridge or building, and provide stability. The diagonal members are designed to carry tension and compression force, while the vertical members primarily handle vertical loads. In simple terms, the Pratt truss is like a framework that helps support and distribute weight by using a combination of vertical and diagonal elements. Its design is known for its efficiency in carrying loads and has been widely employed in various structures due to its stability and practicality. One of the many examples of Pratt truss bridges is Gatton Railway Bridge over Lockyer Creek in Australia. In Malaysia, Mentakap Old Railway Bridge in Pahang. Also here in Johor at Segamat Hanging Bridge.
To start, we need to figure out how much force is pulling or pushing on the bridge when we put on weight on it. By using ideas about balance and turning, along with some math equation, we can find out how strong the force is. We then mark different points on the bridge with letters like A, B, D, and so on. The steps for the calculation are explained. Then, upon completing the computation, it was determined that the reactive force directed toward the bridge support at point AY and KY equals to 29.43 Newton. This determination was reached through the application of force equilibrium and moment theories, considering a load of 58.86 Newton. For the part 3, afterward, we found the angle of the trusses in the bridge system using trigonometric formulas. Each truss angle turned out to be around 45 degrees. We will use this angle data in the next step to calculate the force in each truss. According to the given measurement, we found that the truss in 5 cm tall and 0.5 cm long. To understand the force on the truss, we need to cut the bridge at the point where the load is, and look at a cross-section of the truss. For the part 4, according to the given measurement, we found that the truss is 5 cm tall and 0.5 meter long. To understand the force on the truss, we need to cut the bridge at the point where the load is and look at a cross-section of the truss. The truss had a load of 58.86 Newton right at the middle of the bridge, exactly 0.25 from the support point. After that, we started calculating using the idea of balancing force and analyzing moments. Based on the preceding computation, we derived the force OP at 147.15 Newton, EF at 117.62 Newton, both in tension, and OF at negative 41.62 Newton or compression. Additionally, Truss PF has exhibited a tension force of 58.86 Newton, aligning with the applied load. For the last part, then we use the value OP equal to 147.15 Newton and EF 117.62 Newton. Calculate the value of NO 118 Newton, OE equal to negative 29.69 Newton using equilibrium of force as we appoint a point O as reference point. Following this, we utilize the value NO at 118 Newton and OE at negative 29.69 Newton to determine the force DE at 88.31 Newton and NE at 41.98 Newton. This calculation was executed employing the equilibrium of force, designating point E at the reference point. In addition, we proceed to analyze point and using the same methodology as before. This yield value of N at 8.30 Newton and ND at negative 29.70 Newton. Extending this analysis to point D, we obtain CD at 59 Newton and MD at negative 42 Newton. We continue to calculate the thrust with point M and C as reference. Thus, we gain the value of LM equal to 59 Newton, MC equal to negative 29.7 Newton, BC equal to 28.9 Newton, and LC equal to negative 42 Newton. Lastly, we use point L and point B to calculate the remaining value, which we gain the thrust force is AL equal to 40.87 Newton, LB equal to negative 0.8 Newton, and AB equal to negative 28.9 Newton. I think that's all from me. Thank you.
Assalamualaikum. My name is Ifan Haziq bin Zahid Anwar. So I want to talk about the conclusion of our project. In conclusion, our project successfully applied the thrust analysis method acquired through static education to the design of a brick. So methodology simplified the analysis process and allowed us to understand how force act on the thrust and support reaction. We recognize the crucial role and structure analysis in mechanical engineering, particularly in brick design, and the significance of thrust analysis in enhancing structure, reliability, and strength. This understanding also has the potential to lead to cost saving in construction. That's all.